Okay, we'll start the class. Good evening. This is Saravanan, PhD Scholar and Prime Minister Research Fellow of Department of Civil Engineering, NIT Tiruchirappalli. So, I am a PMRF scholar. So, as a part of PMRF deliverable, I am taking problem-solving sessions in NPTEL for the course Municipal Solid Waste Management, which was originally taken by Dr. Ajay Kalamdad sir from IIT Guwahati. So, in this 2-hour session, the first 1 hour will be we are going to discuss the same lecture material what sir has discussed in the videos, and in the second 1 hour we are going to discuss about the old assignment problems. Okay, so we'll continue the lecture. Yeah. So, so we are in the 10th week of 12-week course. So, in the first 9 weeks, we have discussed about what is solid waste and how the solid waste got generated. What are the types of solid waste on the basis of different source of generation. And we have discussed about the 6 functional elements of solid waste management. First is waste generation, primary collection, handling and storage, secondary collection, transfer and transport, processing, that is physical processing, then transformation, which is chemical transformation or biological transformation. There we have discussed about the windrow and anaerobic digestion. And in the sixth functional element, we are going to discuss about the disposal. So in the last week, we have started the disposal. The major method of disposing is landfilling. So we have discussed about what is landfill and what are the major problem associated with the landfill. One is landfill gas, another one is leachate. So last week we have discussed about the leachate characteristics and how to collect, store, and treat the leachate. This week we are going to discuss about the other major issue with the landfill, that is landfill gas. Okay, that's what we are going to discuss here. And then in the second half, we are going to discuss about the biomining process, that is a novel treatment method for clearing the landfill sites in India. Okay, and some of the landfill design problem also we are going to see in this week. Okay, we'll continue the session. So we are going into the landfill gas. So the landfill gas will be generated by two mechanisms. One is a gas generation mechanism governed by two mechanisms. One is gas generation mechanism, another one is gas transport mechanism. Okay, so three major causes for landfill generation are: first is volatilization, and then biological decomposition, then chemical reaction. What are the volatile solid waste, that is matter present in the solid waste, that will automatically convert into solid to gaseous form, that will give that will accommodate as landfill gas. Then biological decomposition, due to aerobic and anaerobic decomposition, lots of gas, that is majorly methane and carbon dioxide, will be produced, and some chemical reaction will oxidize or reduce the solid waste, and it will be transferred into gas. Yeah. Uh, Sir, can you mute yourself? Thank you so much. So we are discussing about the landfill gas. Okay. So the two major mechanism that is governing the landfill gas. One is landfill generation. Second one is gas transport mechanism. Three major causes of landfill generation are volatilization, biological decomposition, and chemical reaction. First is volatilization. So any landfill gas that will try to be in equilibrium always. So we need to achieve the equilibrium, that is called vapor concentration equilibrium. So that can be accelerated by biological activity. Whenever the biological activity increases, this process of landfill gas generation will also be increased. This depends on the physical and chemical properties of the solid waste in the landfill. Okay, so the law governs this volatilization mechanism is Henry's law. So this law mentions that the extent of volatilization of a contaminant dissolved in the water, how much it can dissolve, that is directly proportional to the amount of gas that will be dissolved in a given volume of liquid at constant temperature, is directly proportional to the pressure that the gas exert above the liquid. Okay, if the pressure of the gas on the liquid surface is more, then there will be more chance of dissolving the gas in the liquid. So that is called PA, that is the partial pressure of a compound A equal to Henry's constant into mole fraction of the compound. Okay, so that's called Henry's law. Then second mechanism, what we have, second and third mechanism are biological decomposition and chemical reaction. Got it. So we are, as we already discussed, we have five phases of landfill gas generation and generation. So in the fifth phase, it will be maturation stage. All the gas generated will be at the constant level. Okay, in the first phase, it will be aerobic, because whatever the gas that solid waste that is contained in the landfill will have some accumulated oxygen present. So this oxygen will be used initially to decompose the solid waste, that is called aerobic degradation. Then all the oxygen will be depleted. In the from the second phase onwards, it will be converted into anaerobic biological decomposition process. That's why the carbon dioxide will start generated, and then after third phase, methane will get generated, and in the fourth and fifth phase, it will be stabilized. Okay, hydrogen will be generated in the second phase. Oxygen will get depleted in the second phase itself. Maximum in the first phase itself, it got depleted. So, based on time, you can see this uh, gas generation pattern will change. Okay. So there are four phases of decomposition, as we already discussed in the anaerobic decomposition process also. The first phase is called the adjustment phase or aerobic phase. What are the microbial decomposition starts in the aerobic condition, because whatever the oxygen accumulated, that will be used initially. So the source of aerobic and anaerobic organism are the whatever the soil we are using as a daily cover and as the final cover. That soil will have some microorganism that will act as a source of aerobic and anaerobic microorganism. Okay, so this is the waste C6H10O4 that will be added with the water, that will be converted into simple glucose, that's C6H12O6. So that's the first phase, that is aerobic phase. In the second phase, that is called the acidogenesis phase. Acidogenesis phase is acid formation phase. So what are the simple molecular, this first phase we can also call the hydrolysis phase. We are adding water to convert the long chain fatty acid into simpler sugar forms. Okay, so in the second phase, the simple sugar will be, yeah. So in the second phase, yeah. So in the second phase, that is called the acidogenesis phase. What are the simple organic compound that is generated in the first phase will be converted into acids. That is called volatile fatty acids. So while the acid got generated, the pH of the leachate starts to drop, and the presence of organic acid will be elevated. And also the level of CO2 liberation will also get elevated. So in this stage, oxygen will be depleted, anaerobic condition begins to develop. Only in the first phase it will be aerobic. From second phase onwards, it will be anaerobic. Okay, so all the simple organic compound are converted into acid forms. In the third phase, that is called acetogenesis phase, all the acid will be converted into acetic acid. So in the second phase, acid will be formed. In the third phase, acids will be converted into acetic acid, that is called CH3COOH. All the acids will be converted in the form of acetic acid. So here CO2 is the principal gas generated. So we are going to discuss only about the landfill gas generation in these four phases. And the pH of the leachate got dropped because again it's acid generation phase only, and the COD by BOD ratio of the leachate increases significantly. And many essential nutrients are also removed in the leachate. Like essential nutrients will be lost from the system because of the acid formation. All the nutrient will get precipitated or it will be evaporated. Then the fourth phase is called methane fermentation phase. All the acetic acid that is formed in the acetogenesis phase will be converted into methane and carbon dioxide. So this is called acetic acid CH3COOH will be converted into methane and carbon dioxide. Okay. So the organic acid and hydrogen. So there are two pathways again. One is acid pathway, another one is hydrogen pathway. Acetic acid, when it is converted into methane and CO2, that is one pathway. Whenever H2 and CO2 got reacted and CH4 is formed, that is called a hydrogen pathway. Okay, so organic acid and hydrogen get converted into methane and carbon dioxide by methanogens and methane formers. So the acid formation rate is considerably reduced because all the acid will be reduced, it will be converted into methane. Here also the pH rises to more neutral form. Initially the pH was constant, again it got dropped due to the acid formation, again now it will be converted into more neutral form. That's why whenever the leachate pH is alkaline or nearly neutral, that is called a stabilized leachate. Whenever the leachate is having acidic condition, then it is called a fresh leachate, or it is generated from the fresh solid waste. Okay, and then the fifth phase is maturation phase, where readily available organic matter has been converted into methane and carbon dioxide. Landfill gas generated diminishes. All the solid waste got matured, and no more organic matter present, so no more methane and carbon dioxide will be evolved. Here again, the gas evolved is methane and CO2. Depending on the landfill closure measure, small amount of nitrogen and oxygen gas may be there. So you can see here, small amount of nitrogen will be there, 2 to 5% will be there. Majorly, it will be methane and carbon dioxide around 60% and 40%. Okay, so this landfill gas generation will be affected by different factors. First one is waste composition. So everything depends on the waste composition only. More organic matter, more gas generation. Then temperature. If the temperature also governs the chemical reaction, so that will be converted into gas. Then moisture, pH, atmospheric condition, landfill cover, waste density, and waste age. So these are all waste age again governs, because if the time increases, the anaerobic condition will prevail, and again it will be given to maturation phase. Okay. Then the transport mechanism. First is landfill gas generation. Second one is landfill gas transportation. So the transport of landfill gas can be covered by diffusion and advection. These are the two principles: diffusion and advection. Diffusion is the one which the movement of gas in the direction of concentration decreases. So whenever there is a high movement of gas from a high concentration to low concentration, that is called diffusion. Whenever the transport of gas from high pressure to low pressure region, that is called advection. So diffusion is governed by on its own, advection is governed by some pressure movement. Okay, so this is concentration based, this is pressure based, advection is pressure based. So diffusion flow of gas in the direction in which concentration decreases. So concentration gradient we have to find. Wherever the slope is higher, it will move on that direction between the surface and the interior of the landfill, and promotes the migration of vapors. The geomembrane in the landfill cover will significantly reduce the diffusion. If there is no cover or no geomembrane or any clay liner, then there will be a huge movement of landfill gas. Okay. Then advection. Advection is the rate of gas movement that is generally covered on the order of magnitude faster for the advection compared to diffusion, because whenever we are applying some pressure or due to some atmospheric pressure difference, high pressure to low pressure region, the gas will flow. That process is called advection. It will be always greater. The rate of advection will also be always be greater than diffusion mechanism. Okay. So again, this transport mechanism will be governed by different factors. First one is permeability. Whenever the waste permeability is higher, then the gas movement will also be in higher rate. Okay, and has a larger influence on the gas flow rates and the gas recovery rates. Coarse grain waste exhibits larger volume of gas permeability, and then fine grain particle, if you see, it will be densely packed, and the movement of gas will be restricted. Okay. Then the geological condition. A geological condition was determined to estimate the potential of off-site migration of the gases. The landfill is a contained system, but what are the underground and the sideways geological condition? The historical rock or geological pattern that will also affect the movement of the gases. Then depth of the groundwater. The water table surface will also be acts as a no flow boundary for gases, because whenever the water table is there, the gas flow will get restricted. So the water table acts as a no flow boundary for the gases. And during design period, this water table upwelling will be assessed, and it will be taken for consideration during design process. Okay. Then the man-made features. Some of the underground utilities like storm and sanitary receivers and the electrical cables and shortcuts of this that will act as a short circuiting for this airflow. Okay, so that are again a factor. And then the landfill cover and the liner system. Whenever we are having a vegetated surface component or a geomembrane, geosynthetic clay liners, these are the type of clay liners we had already seen. So whenever there are more liners, then the gas movement will be restricted. So geomembrane is the cover system will prevent the intrusion of gas into the waste. Finally, the barometric pressure. Whenever the amount of gas escaping from the landfill surface changes, as the barometric pressure changes, this is called advection. We have discussed already. So, the movement of gas based on the pressure difference from high pressure to low pressure, the gas movement is called advection. So, this again will be we can classify the landfill gas collection system into two things. One is passive landfill gas collection system, and one is active gas collection system. Passive in the passive gas collection system. Increase in the atmospheric pressure decreases the gas flow because the pressure difference between the inside and outside of the landfill gas decreased. In active gas collection system, we are giving a vacuum pressure to collect what are the landfill gas that is generated. In passive landfill gas collection system, whenever the atmospheric gas pressure get decreased, this landfill gas will be collected. But whenever in active gas collection system, we are applying some vacuum pressure to extract the landfill gas that is generated. Okay. So you can see here impact, relevance, and trends of gas phase emission. These are the different types of gas landfill gas components and their emission trends. How the movement will happen. Majorly, we have two constituents of landfill gas. One is methane, that is 30 to 60%. Another one is carbon dioxide, 20 to 50%. Some other landfill gas components are there which will be present in minor quantities like aromatic hydrocarbons, halogenated hydrocarbons, CFCs, chlorofluorocarbons. Everything is global warming gases which will have a higher potential of potential for global warming, and these are all greenhouse gases. Okay. Then some PCDs and PAH, polyaromatic hydrocarbons, and other NMOCs, and hydrogen sulfide. This is around 20 gram per meter cube, very small quantity, but it is having huge impact. You can see the types of impact. Everything has some health effects and environmental persistence, more corrosion for the pipes it will create. And organosulfates, carbon monoxide, hydrogen, mercury, silica compounds are the major impurity in the landfill gas. Because what are the silica compounds that will clog the pores? And then ammonia, nitrous oxide, nitric oxide, dust, and aerosol. You can see the movement pattern also, how it will move through the landfill solid wastes. Then the design of landfill gas systems. So we have lots of components like gas wells, tubes, and then pipe works, collection system. Everything we are going to discuss in the design part. Okay, so the design of gas well. So it's based on the performance quotient for wells, that is meter cube per hour per millibar. So here we have a rule called 6 bar rule, that is called rule of hundreds. That whenever 100 meter cube per hour flow is there in a 100 millimeter dia pipe having a length of 100 meter, which will give a pressure loss of 6 millibar, that is called rule of hundreds. I'm coming back here. Everything is based on the length, diameter, and flow rate, okay, of the gases, landfill gases. So this gas well is based on the site containment, temporary capping whenever the daily cover is given or not, and then permanent capping, that is the final cover, and then the site linings. Okay. Then optimizing the gas well based on the gas velocity, maximizing the effective length, and providing contingency measure. Gas velocity can be minimized by making a well diameter, making the diameter large, and the effective length can be maximized by keeping the gas at the wellheads. Here again, I am coming here. The design of pipe work. Pipe, you can, if you are a civil engineer, you have studied in fluid mechanics. Whenever there is a flow in pipe, fluid flow in pipe, gas is also a fluid and water is also a fluid. So the same principle will be applicable for gases also. The same thing will be for landfill gas also. Whenever there is the landfill gas is flowing in a pipe, there will be a pressure loss. The gas flow always gives a pressure loss. Okay, so this pipe specification based on outer dia and the pressure rating, and then the standard diameter ratio, that is called SDR. The landfill gas type typical pipes are 6 bar, SDR 17.6. These are the pipes we are going to use for landfill gas collection systems. Okay, that is how the pipe works. Specification you can say 6 bar, SDR 17.6. So the glass flow always gives pressure loss. So this loss of pressure is directly proportional to the gas flow rate, that is meter cube per hour. How much gas is flowing per meter cube of gas is flowing per hour, that is Q, flow rate. So this loss of pressure is directly proportional to Q, and then it's indirectly proportional to inner diameter and uh, length of the pipe. So that's what given here, Q square by ID power 5. So whenever the flow rate is increased, the pressure loss will be decreased. Whenever the internal dia got increased, the pressure loss will be decreased. So this pressure loss is due to friction in the pipe. So whenever the dia got increased, there will be less friction. So you can reduce the pressure loss. Okay. So the rule of hundreds you can follow. 100 meter cube hour of flow of landfill gas in 100 ml dia pipe at 100 meter long, which gives a pressure loss of 6 millibar. Okay, this is the thumb rule, you can say, hundreds rule, you can say. And then the gas collection system, as I mentioned, the passive gas collection system, it's based on the difference in the pressure between atmosphere and inside the landfill solid waste. So the passive collection system can be installed during active operation of the landfill and after closure. So the collection will are typically constructed on perforated and slotted plastics, you can see here. So these are the perforated and slotted plastic that is used to collect the landfill gas. So it will be transported through the uh, perforated material, and it will this can be installed vertically throughout the landfill. So 50 to 90% of the thickness will have this perforated materials. Horizontal well can also be located below the surface ground surface. But in active gas collection system, it's also having vertical and horizontal gas collection system. But these are all having valves to regulate the gas flow and to serve as a sampling port. But there is no valve for passive collection system. But here we have a vacuum creation mechanism to collect all the landfill gas that is generated. So this actually is a system to pull the gas from the landfill. There, the size, type, and number of vacuums are required. Okay. So the effective active gas collection system will be designed based on the gas moving equipment, collection well, and the number of spacing between each extraction well. This number of spacing will be defined depends on the waste type, depth, compaction, pressure gradient, and moisture content, and the ability to monitor. So we can only monitor in the active gas collection system because this is having valves and ports. So we need valve, pressure gauge, condenser, and the sampling port at each collection well to collect sample or landfill gas sample, and for to monitor pressure and measuring gas generation rates. And then the collection head. So initially we have discussed about the collection well, and then landfill pipe, gas collection pipes, and then gas collection system. Now gas collection head, collective head, we are having two types. One is collective head, another one is individual head. Here you can see individual head, another one is collective head. So in individual head, each there is a single pipe for each well that will be finally taken to the gas collection system. But in the collective head, all the pipe will be all the wells are connected to a single straight line pipe, and it will be interconnected. That's called the collective head. So it will be connected to a main header which supplies the gas to the gas collection system. But here each well will be taken out with I can draw here. Each well will be taken with a separate pipe to the gas collection system. So that is called individual header. Okay, that is called individual header. So in collective header, all the wells will be interconnected with the different pipes, horizontal and vertical, that will be extracted later. Ma'am, can you mute yourself, please? Thank you so much. So this again we are going to discuss about the gas collection stations. So the gas collection station having different components. First one is the central collector, blower, filters to remove solids. As I mentioned, the solids are the major impurity present in the landfill gas. Then reservoirs to store the landfill gas if you are converting it into energy form. And then instruments for control of gas extraction and transport, and then measuring and control equipments. Then emission monitoring. So we have to have a landfill gas control system. Emission rate estimates are monitored by technical. It should be monitored based on the technicality and the economical feasibility to recover and use the landfill gas for energy production. So only, when the landfill gas generation rate is important. If you are not getting the enough landfill gas, then the energy production system will fail. So we need to have a proper plan before planning for a gas to energy production, landfill gas to energy production. So this monitoring of gas, we have 5 categories. One is soil gas monitoring, near surface gas monitoring, emission monitoring, ambient air monitoring, indoor air monitoring. So that's what we are going to discuss here now. So you can see here, first is soil gas. So how we are monitoring and typical parameters and the relevant public health we are going to see. In soil gas, we are going to measure the concentration of chemical in vapor space of the soil. So as you know, we have porosity for any type of soil or the solid waste. So what are the chemical of concentration of chemical that is present in the pores of the soil or the vapor space of the soil, that will be monitored here taken at the depth and use with the help of probes or wells. So what are the parameters we are going to monitor? Oxygen, carbon dioxide, and nitrogen are frequently reported. Sometimes hydrogen sulfide and NMOCs. NMOCs are non-methane organic compounds. So this will create some public health issues because the level of methane is the only concern which will have a risk of explosion because it will create fire. It will catch fire easily and migrating into the soil to off-site location also. So this case study you can see with NSWI case study report that I will discuss in the extra class. We are having one extra class after 12th week. Well, on 22nd of October. In that we will discuss about this type of case studies, okay. And then near surface gases. So the concentration of gases at the point not higher than 4 inch above the ground surface. So at the landfill site surface itself, if we are measuring the concentration of the gas, that is called near surface gases. Only methane will be monitored. How much emission we can monitor easily. So this will indicate high level of landfill gas escaping or not, we can easily measure. So this landfill gas collection and control system is working well or not, that also we can justify based on near surface gas monitoring system. Then emission monitoring. Emission monitoring is the one we will measure the chemicals that are released from a particular source, like landfills or a flare or a stacks. So how much emitted, that if we want to measure, that's called the emission monitoring. So here also we will mainly measure methane and the NMOCs. So again, methane is an organic compound, non-methane organic compounds we will measure. And then ambient air, in the ambient air level of pollution, outdoor ambient air we will measure. Ambient air is, it's a surrounding air, we can say, so that the people are breathing. So wide range of pollutant, majorly the criteria pollutant, you can know in air pollution, you have studied about the criteria pollutant like particulate matter, lead, carbon monoxide, NOx, SOx, nitrogen oxides, and SOx, sulfur dioxide, and then lead. These are the 6 criteria pollutants of ambient air. Okay. Then the major problem is this is the ambient air that people are breathing, so it's having a major health issue, health related impacts measured for air exposure concentration in the vicinity of the landfills. Then indoor air quality monitoring. This is the level of contaminant present in the indoor air, that is inside the home or inside any institutional premises or office premises. So indoor air monitoring for methane is performed to address the site specific concerns. This will be evaluating the risk of explosion, exposure to contaminants within the home. We can mention measure, and then emission from the household harmful products like any volatile product, like if you are having paint or anything, will have some volatile compounds. This emission also we can measure with the indoor air quality monitoring systems. Okay. Then direct methane measurement also we have like a flux chamber testing, plume measurement, and the dispersion modeling. These are the 3 direct methane measurement techniques. First is flux chamber techniques. In this, the methane flux will be converted. Methane flux is methane, mass of methane emission per area. So from 1 hectare of landfill, how much methane is emitted, milligram of methane or kg of methane emitted. That's called methane flux at a point on the landfill surface using flux chambers. So this is again a laboratory scale. So no industry accepts standard methods for explorating and of site-wide emissions. Then plume measurement. This is a ground-based optical sensors to measure the methane plume. Methane plume in the sense it's like a ball or a bubble kind of thing. How much methane plume are emitted? So that will be calculated in landfills methane emission rate. And then air dispersion model. Air dispersion modeling is we know how much air background air that is present before emission. Now we know how after constructing the landfill we know the concentration of the methane. So with this air dispersion modeling formulas we can calculate how much methane is generated on site, and downwind methane concentration also we can find. If modeling you will be studied if this is the landfill, and we have methane emission rate of like if you see 500 meter cube of methane is emitted per day from the landfill, and I am having the wind flow in this direction. Then after 10 kilometers from this landfill, how much methane will be there? Methane concentration will be there, and the background methane concentration here is very less, like 0.5 meter cube per meter cube is there per meter cube of air, or kg you can say. Okay, per meter cube of air, if you take 0.5 meter cube is sorry 0.05 meter cube is the methane concentration. Then if this is the wind flow direction, then how much methane will be there here after traveling to 100 kilometers based on different meteorological parameters like wind direction, wind velocity, pressure, and based on the type of pollutant this we are taking methane, and the background concentration, everything will be taken into consideration in the air dispersion modeling. So we can take a box model. We can assume different formulas are there. If you studied air pollution, you know about box method, box method, and then the major one is plume rise you have studied about. In plume rise, if there is an industry and we are emitting some gas, there is a emission from the industry. So if this much of particulate matter or sulfur is getting out from the industry, then after 10 kilometer, how much sulfate will be in the ground level, or how much sulfate will be in the height of 1 meter. Like that we can calculate. These are all monitoring methods. Okay, you can say. Okay. So now, for landfill gas, we have important modeling mechanism. So all the models should follow an order. So every chemical reaction will follow one order. So if you consider this as a zero order decay model, waste is assumed to be constant with time. So if you are taking the quantity of the waste, that will be always constant with time. So effect of waste age is not incorporated in the model. The directly we can calculate because this is a zero model, so there is no change in the zero order is based on the time. The rate won't change. Rate of decay will be always constant. So rate k will be always constant with the time. Okay, you can see this is the time. So this is called a zero order. If it is first order, the rate of decay will be linearly increasing. That's called the first order decay. Okay, but the landfill gas, that is every time we are mentioning about methane generation only, because methane constitutes about 60% of the landfill gas. So the L naught, that is the ultimate methane generation potential, is the governing factor in all the models. How much methane generation, that is a rate Q, and then ultimate methane potential generation potential, and time, mass of solid waste present in the place. So in the landfill, this much quantity, this much tons, a million metric tons of solid waste is there. Then how much methane will be produced? We can calculate with this model. if it is following the first order decay model, whenever the waste is decaying, methane is generated. That's the basic principle. But order we can fix. So EPONET, you know about LandGem model. You can go through the Google. You can find about LandGem. LandGem is a model used, a software or a model you can say, that is used to find how much landfill gas generated from a landfills. That is designed by Environmental Protection Agency of United States. So that was developed by Environmental Protection Agency of United States. So in this model, the amount of waste is assumed to decrease exponentially. So that's what the waste decreasing. Initially, the waste is like 10 million metric tons. Then with the time, it will decrease. So the rate of decrease will be linear. That's called first order decay. So the model is Q equal to M into L naught e power minus K T minus Ti. So based on time, based on a rate of decay, the based on methane generation potential, the mass of waste will be decayed and the methane will be generated. This is the basic concept behind LandGem model. So the K will be given by first order decay constant per year. Okay, so because it's based on time. And then the modified first order model they have given, because we need to assume methane generation from a certain amount of waste, because all the waste will not produce methane. Some may be glass, some may be stones, some may be metals, many recyclables will be there. Only the organic matter will be converted, decomposed and converted into methane, like food waste, plastic, textiles, and this is a type of organic matter which will yard waste will be converted into methane by biological process. None of the other recyclables like glass, metals, stones, some of the inerts will not be converted into methane. So that also should be taken into account. So that methane generation model having a certain amount of waste may be initially low, and some may have higher degradation rate. So that all will be taken into account. Initial stage how much methane generation rate, and the final stage how much methane generation rate. Then multi-phase decay order. This is considering different fraction, waste fractions we are differentiating. If you are differentiating by time, that is modified first order. If you are differentiating based on different fraction, that is called the multi-phase decay model. These are the model formula that is already incorporated in the LandGem software. Only you have to give how much waste and all the meteorological data, like what is the temperature, solar radiation, what is the area of the landfill, what is the climatic condition, how much precipitation, that is rainfall, how much wind flow and wind direction you have to give. Everything if you give as input to the model, it will automatically take the K value and it will calculate the methane generation rate. Okay. Then LandGem model. So this follows simple first order decay constant as I mentioned. So it's based on the potential of methane generation capacity. So the methane gas potential produced by metric ton of the waste as it decays. So again, it's based on half-life of the waste. Okay, half-life equal to ln of 2 by k. So half-life of the waste is like this. I will explain again in the separate with the problem. I will explain in the problem solving section. Extra special class I will explain. Okay. So we have a default parameter for default table for k to find k value, which have considered 5 different categories. One is based on the Clean Air Act (CAA). Another one is based on inventory type. Inventory type is based on greenhouse gas emission inventories. Okay. Again, it's taking based on the climatic condition. Conventional, that is having rainfall greater than 25 inch per year. Arid regions having rainfall less than 25 inch per year, and then conventional type for inventory, arid type and wet type. Wet is bioreactor type. So all are having this much L naught value, and this is the K value of different type and landfill type. Considering different default parameter, we can easily find the K value and the L naught value. But this will apply only for US condition, because LandGem was developed by EPA in USA. So we are assuming the waste is completely homogeneous. All the waste are of single type and having only one L naught and only one K value. So everything will decay at the same rate. Okay, that is the assumption we have to remember in LandGem. And the model does not include categorization of the waste, because first order multi-phase decay model only considering different fractions of waste in the landfill. But this LANGEM model will not consider any categories of the waste. Other models like Afalzog or the Sweet model developed by US EPA, everything considers different fraction categories. But LANGEM considers only assume waste as a homogeneous material. Okay. Then variation in the moisture content, rainfall, leachate recirculation were not taken into account. That is the limitation of LANGEM. But because LANGEM is not appropriate for countries outside US with significantly different climate regions and different mix of waste type. If the waste is homogeneous, we can adopt this model. Otherwise, we have to calculate our own K value and own LR value in the laboratory by taking the waste from our landfill. Then we can adopt the model equations in the landscape. Hope you got it. Then IPCC model. This is another model which was developed for countries to estimate methane emission using regional per capita waste generation rate is important, population estimates, and a deduction for landfill gas collection and oxidation. So this is the important one. It uses multi-phase first order decay. So it incorporates the degradability of different components of the waste. Not only assuming as waste as homogeneous. So the K value for rapidly degrading, slow degrading, moderately degrading, this type of we can differentiate. Food waste is rapidly degrading. Some of the textile and plastic waste are slowly degrading. Moderately degrading like wood, paper, this type of things we can classify and we can give different K values and we can some of the inert material we can put at 0. So this multi-phase first order decay model is adopted in IPCC model. Here the assumption is first approach assumes degradation of different types of waste is dependent and degradation of different types of waste is completely independent. There are two approaches. Based on different components of the waste, any one waste degradation is dependent on the degradation of the some other waste. So this approach we have to check. This thing we have to check and give the proper assumption. Then IPCC model have some limitations like this model considers only 4 climatic conditions categories represent and improved over LANGEM 2 climate. LANGEM considers only 2 climate category model, but IPCC considers 4 climate model. Still, if you are calculating for any landfills in India, that also we have a different climatic conditions state wise. So North India may have some colder regions that we have to check for different climatic conditions. South India you have to calculate as a different climatic condition, more less monsoon season you have to calculate the K value. Okay. That's the major thing. Temperature has a smaller impact on the landfill generation than precipitation. That is the limitation for landfill. That's the limitation in the IPCC model. When the PET data is not available, the precipitation assumed as 1000 millimeter per year as a threshold. So that is varying in different climatic conditions like dry or wet categories. It will vary because we can't assume one precipitation for the whole landfill sites. But the LANGEM assumes 635 millimeter per year as a precipitation. This IPCC model will be advanced than landfill, but still it's having some limitation to be used in the Indian conditions. Okay. Most of the model automatically calculate collection efficiency, how much landfill gas that is collected, and then overall site condition, waste depth, waste compaction particles, and then size of tipping area, bottom liner. Everything affects. These are the factors that it affects the generation of the landfill gas as well as the transport mechanism of the landfill gas. Next, we are moving with the landfill gas contaminants and their removal. So now we have designed the landfill collection system. After collection of landfill gas, how to remove? We have to first identify what are the contaminant that is present and how to remove this contaminants from the landfill gas. Direct use of raw landfill gas will not be advisable because it may have some contaminants like hydrogen sulfide that is more poisonous than siloxanes. Siloxanes are the solid particles. As I mentioned, this will clog all the filter units that you are going to use, and then the moisture that is present in landfill gas that will reduce the efficiency to use this landfill gas as a energy production system. So the landfill gas need to be treated due to its relatively high content of contaminants. So we have two stages of treatments. One is primary treatment, which will remove first solids, liquid, and gas drying. So solids like siloxanes, and then liquid like moisture, then the gas drying we can do. Then in the second stage, is this advanced treatment. We will desulfur. It will remove first H2S by desulfurization, and then organic siloxanes by removal of organic silicon compounds. Then other harmful gases like hydrocarbons and ammonia will be removed. All this treatment technology will be based on technical feasibility and economical constraints. So in the primary treatment, first we are going to remove solid particle, moisture, and gas drying. So for that we are using first water condensate knockout. Water condensate knockout. Because the presence of because the presence of liquid water, that is a moisture in the landfill gas pipe works, which will have a detrimental effect on the plant performance. So accumulation of this water reduces the space available for gas flow and raises the pressure loss, because whenever the water is present in the landfill gas, that will affect the rise the pressure loss. As we discussed earlier, landfill gas flow in the pipe will reduce the pressure. That pressure loss will happen due to whenever any fluid flows through the pipes. So this pressure loss can be reduced if the moisture in the landfill gas got removed. So with three methods we can adapt. One is liquid water capture, foam removal, then vapor reduction. Then siloxane removal. Siloxane removal, these are the low molecular weight siloxane volatilized into landfill gas. So what are solids that will be directly converted into gas? Again, it will be transferred when cooled down. So that will again be solid. So these selections are converted into silico dioxide and deposited in the combustion chamber. So whenever you are combusting this landfill gas, whenever you are generating energy, this will deposit as a silico dioxide and exhaust stage at the exhaust stages of the equipment. So if you want to check the evidence for siloxane, you can check the formation of white powder in the heated gas turbine components. That will indicate the presence of siloxane in your landfill gas system, gas collection system. So this will be removed by adsorption on activated coal, adsorption in the liquid, because it's a solid particle, can be absorbed in anything like solids or solid adsorption. We can also use liquid hydrocarbon mixture to absorb the siloxane. Gas cooling method. So whenever the gas is cooled down, this type of solids will be removed. Only the gas will be separated. That's called the concurrent water knockout mechanism. So whenever we are reducing the temperature of the gas to minus 70 degrees Celsius, 99% of the siloxane will be settled, and only the gas will be taken out. These are all primary treatment to remove siloxanes and the moisture. In the advanced landfill gas treatment methods, we are removing H2S, siloxane gas, ammonia, aromatic hydrocarbon, and the halogens. Okay, so H2S will be removed because it's extremely toxic, flammable gas and harmful to the environment. So it should not be released. Same like methane, it should not be emitted, and it will be reacts with steam to produce sulfuric acid. That is another important problem. Whenever the H2S is released, it will be reacted with the water. It will form acid. That's why these are all the reason for acid rain also. And then effect on the effect. This will have a significant effect on the useful life of the landfill gas plant. So different methods are there. We can choose based on the economics feasibility. So like biological desulfurization, treatment with iron chlorides, water washing. Water washing will remove H2S. We can also remove H2S by different chemical treatment methods. Activated carbon, iron oxide and hydroxide, sodium hydroxide. These are all the chemicals we can use to remove H2S. It will react with rapidly with H2S. So what are the expenditure it's having, and throughput rate is efficiency of removal. So high removal efficiency and low cost, low operation and low capital expenditure is for iron oxide and hydroxide removal methods. Then other landfill gas contaminants like ammonia, aromatic hydrocarbons, and halogens will be detected in very low concentration. Even if it is present in a very low concentration, it's having a huge health impacts. So ammonia, if it is present below 0.1 milligram per meter cube, aromatic hydrocarbons 1 milligram below 1 milligram per meter cube, and halogens below 0.1 milligram per meter cube, it will facilitating immediate use of gas without the need for any other treatment system. So these are the limits for different contaminants in the landfill gas. If it is present below this concentration, you can directly use the landfill gas without any treatment. So these are the landfill gas to energy technologies. You can use the boilers fueled with this landfill gas instead of any coal or uh, natural gas. You can use this landfill gas as a source of energy. Okay, boilers. You can use landfill gas alone, or you can use landfill gas along with some other fossil fuels. That is called a combined technology. Then direct thermal application like kilns, you can use directly. You can fix the landfill gas into the kilns that will be incinerated along with the sludge dryers, infrared heaters, not with any other important environmentally important things we have to. Only like this type of sludge dryers. Again, this waste gas should be used to treat some waste only. So that type of mechanism we can adopt. Okay. Like we can also use this landfill gas to evaporate the leachate because leachate treatment we have studied. Leachate evaporation is the cost effective method to treat the huge volume of it's not cost effective, it's a simpler method, technically feasible, but it's having a higher cost incurred in the project due to the heating mechanism. But if you are using this landfill gas as a landfill gas to energy and using as a source of heat for landfill leachate evaporation, then it is economical and reduces the cost of treatment and disposal of leachate. Then biomethane production. Biomethane is a gaseous fuel. Again, it's similar to the natural gas. So it can be injected into gas grids. Again, it will be used to generate energies. Landfill gas can be upgraded to biomethane by removing CO2 because it's having 60% methane and 40% CO2. Whenever this CO2 is removed, this 60% of the methane concentration will be higher. And other trace contaminants will also be removed, like ammonia, hydrogen sulfide, and siloxane. This landfill gas can be converted into biomethane that can be used as a similar to natural gases. So how to remove CO2 from landfill gas? By using adsorption techniques, physical and chemical adsorption, membrane separation. Lots of studies are going on with the gas separation mechanism by using membranes, and then cryogenic treatment. Cryogenic treatment is like chill out method, what we have seen to reduce the temperature of the landfill gas to reduce minus 70 degrees Celsius. Below that, all the silicon particles will get settled. Like that, carbon dioxide will get removed because different gases will have different condensation point. So the process of different only in terms when the utilized technique in terms of achievable gas quality, the process behavior and experience with which they can be used. So everything is based on the practical suitability. So these are the different techniques we have seen there and the comparison. So adsorption, it will absorb the CO2 in a molecular sieve. In physical adsorption, we can dissolve the CO2 in water. In chemical adsorption, we can dissolve the CO2 in MEA, that is a chemical. And membrane separation, we can use a permeable membrane to remove H2S along with the CO2. And then the H2S and the CO2 concentration are higher than CH4. We can use the membrane separation because only the CH4 will get removed. Okay. Yeah. Then in the cryogenic technologies, it's a low temperature process that will use phase transformation of the CO2 to liquid. That's again a phase transformation mechanism like chill out. So you can see the efficiency is 99% for cryogenic technologies. You can also study about the cryogenic fuel. Everything is based on the same principle. And then the reason for landfill gas control, why we need to prevent and control and treat landfill gas, because it will create air pollution, it will be hazardous to the human being, and whatever the landfill gas that is generated will also migrate to the off-site, and it will also affect the human settlements. Okay, then prevent this case study I will teach you in the extra class. And then the prevent damage to the landfill cover slope stability, because the whenever the gas is trying to escape, the slope stability will also get disturbed. Okay, then the other control and the energy recovery. These are all the reason to control the landfill gas. Okay. Now we are going to, these are all about the landfill gas. So last week we have discussed about the leachate and the leachate treatment methods. Now we have discussed about the landfill gas and landfill gas treatment, collection and treatment methods. These are the two important contaminants from the landfills. Now we will see two small problems on design of landfills. Okay, so here we are. Here is the first example. Asking us to estimate the landfill area required. So if I am going to design landfill for Tiruchirappalli, so I will first calculate how much population in Trichy. If it is 1 lakh population, okay, and then each person is generating around 2 kg of waste per day. Okay, then 1 lakh into 2 kg will be 2 lakh kg uh, per day. That is the solid waste generation rate. If I want per year, I will multiply with 365. So that much waste is generated. So I have a allowable height of 6 meter. Okay, so everything is in kg. Now I want to convert this kg into meter cube. So I want the density, compacted density, because in landfill it won't be a direct application. It will be fully compacted. Sorry. So it will be fully compacted. So the waste compaction rate we have to check, density, compacted density. So that will be converted into meter cube. Then you can divide with the maximum allowable depth. Then in as per CPCB we can go up to 20 meter, but the average depth of the compacted solids given in the question itself 6 meter. So if you divide by 6 we will get the area required. So we have the volume, we have the height, and we can easily find the area required. So that is simple formula. If you are assuming as a cube, okay. So we have 31,000 as the population, 2.9 is the daily generation rate, and if you divide by 1,000, you will get in tons. And if you divide by the density, you will get in meter cube. And if you divide by the depth, you will get area required per year. Then if I have if I have 3 hectares, 40 hectares of area, and then if I divide by 1.15, I can use for 35 years or 37 years. So that's the landfill life I can go up to. Okay, after 37 years, I have to check for some other area for the disposal of solid waste. And if you want to design in more precisely, you have to have some buffer zone, like 20 to 40% as a buffer zone for service building, access road. You can't use the whole area for solid waste alone. We need some monitoring mechanism. We need some service building, utilities, access, everything. We need roadways. We need inside the landfill also. We need some road transport mechanism. For that, we need to give 20 to 40%. So you can add 1.12, oh sorry, 1.2 or 1.4, and you can get the final area required. Also, you can consider some contours and the effect of gas production and overburden system, and landfill gas collection and leachate collection system will also have some require some area. So if you subtract that, what are the remaining area? That is only for solid waste. And if you are considering only as a cube of 6 meter, and this will always not be like cube, so will be like a trapezoidal shape. So this area will not be taken into consideration in practical situations. So you have to subtract this area also. Only this area will be used for solid waste storage. That also you have to take into consideration when by considering the slope. In the second question, we have given with we have asked it to find the density of the compacted solid waste. So we have given with different fraction of solid waste and their percentage composition and their specific weight and the compaction factor. So easily we can find the density of the solid waste. How to find the density of the total waste if we want? So we have different types of waste. We have composition. We have the specific weight. So it's in decimal. So I want to convert this into a numerical form. So I can directly multiply with the 10 with for all the values. So I will get total as 1000 kg. Okay, if I multiply, or else you can directly do without multiplication also. So volume you can calculate by dividing the weight with the density. So we have 90 by 291 is the density. You will get 0.31 is the volume. But 0.31 is now actual volume, but compacted volume will be 0.33 is the compaction factor. So if I multiply with this volume, I will get 0.102 as a compacted volume. So total compacted volume is 1.8. Total weight is 1000. So again, this mass by volume 1000 by 1.8 will give you the compacted density. There is a specific weight of the total solid waste. Then they are asking to determine the impact of resource recovery. If I am taking 50% of the paper waste, so how much paper waste is generated? 34. So I am taking 50% of the paper waste, 80% of the glass, and 80% of the tin can. Then how much density will be reduced? They are asking. What is the impact on the resource recovery? So I am recovering these resources. What is the impact on the density? So if I am recovering total 1000 kg, I am reducing 0.5 percentage of paper, 0.8 percentage of both glass and tin. So I will get the final weight. Same I have to subtract from the volume. So final weight by volume will be 552 kg per meter cube. You can see here uh, 556 and to 552. Only 4 kg got reduced. So it's not having much impact in the density if you do resource recovery. But if you check about the space requirement, it will be having a huge impact. Okay. So this third example I will explain you during the extra class of problem solving session. Also some more landfill design problems I will explain. Okay. Here we are coming to the last module of this week, that is biomining. So the major problem with the solid waste management is there are two major problems with the solid waste management. There are two major challenges we can say. One is to manage the continuous flow of solid waste on daily basis. Daily I am generating waste, so I need to have a proper system to manage daily waste and then dealing with the legacy waste. So if I am checking for the techniques to solve with the daily problem, what can I do with the already disposed waste of last 1 century or more than that? I have disposed the waste in the dump sites. So how to deal with the legacy waste in the dump sites? Legacy waste are the waste which is having age more than 15 to 30 years in the dump site, that are all called legacy waste. Whatever we are generating today are called fresh waste. So the major problem is to check techniques for the fresh waste and to deal with the huge quantity of legacy waste. If you assume this type of how much quantity of legacy waste is present, you can check with the Delhi. There is a Ghazipur, Okla and Balswa landfills. You can see the height of about 63 meters, 55 meter, 56 meter. You can see huge mountains, a huge height of mountains present in old dump sites of having a huge quantity of legacy waste. So in India, based on a report, CPCB report, you can check 10,000 hectares of urban land is locked only in the dump sites. We have in India more than 3,082 plus dump sites in India, having occupied 10,000 hectares of urban land. If you take 1 acre, 1 meter square of land area, 1 feet square, how much it is in your area? If you check dump sites in your area and calculate the cost of the land, it will be huge. So we are losing lots of useful land. We are also creating environmental impacts. So not only the land, other problems like landfill gas, which cause global warming, leachate, which will pollute the groundwater. So all the municipality, they have started capping as an option. Capping is dragging all the waste to one area. If I am having 50 acres of land dump site, so all the area having solid waste. So I will drag everything to a common location of around 50 to 10 acres. Or 50 acres of total land, I am dragging all the waste to this 10 acre, and I will cover with the proper cover system. What we are doing for the scientific landfill design, like that I am doing, and this 40 acres will be recovered. So this is the first idea they have proposed in all the municipalities. But this also have, because we are not having any liner at the bottom. Again, all the waste accumulated in this 10 acre will produce leachate. Even though we are having top cover system, bottom we are not having any liner system. So rainfall will not percolate, but the leachate that is produced from the landfill will percolate into the groundwater. So that is the problem. That's why the capping is not the first option or in the order of priority. as per the solid waste management rule J class of schedule 1. So, in solid waste management rule 2016 itself, and rule 15, it is mentioned it is the duty and the responsibility of the local authorities, or village panchayat, or center towns and the urban areas to check the feasibility for biomining, to check the potential for biomining or bioremediation in the old dump site in their locality. So if I am in Trichy, the local authority of Trichy, it's their responsibility to check the old dump site for the feasibility to biomine and bioremediate. If there is the options of potential for biomining, it should be scientifically capped. That is the second option we have to follow. You got it. So biomining is the process of excavating all the waste in the landfill and segregating into different fraction, and we can use the different fraction for different application. So the land will be cleared, all the waste will be used for some other purposes, so that there won't be any environmental hazards. So first they have taken into environmental hazards is the first point. The second one is land area. Okay, so we are going to discuss about the process of biomining. So first we are mining the legacy waste. Why we are calling as biomining? Because bio is the word given because what are the waste in the landfill in India are mostly organic, and we are also doing bioremediation. So these are the two reasons the word biomining came. Mining is again we are excavating the waste. That's why mining. Okay, after excavating the waste, we are there may be some non-degraded materials. So that we are accelerating the degradation process by adding some biocultures. That's called stabilization process. We are aerating because it's an anaerobic condition inside the landfill. Now we are taking out and aerating with the biocultures, and then screening of waste into different fractions based on simple physical separation process. We are segregating the waste into different fractions, greater than 150 mm, 80 to 100 mm, 30 to 50 mm, less than 30 mm, and then 4 to 6 mm. This finest fraction is called bio earth or good earth. So this landfill or mining, this biomining process you can see in some of the literature as landfill mining. In other countries they will call us landfill mining. In India we will call us biomining. So the finest fraction is called bio earth. That will also called soil like material SLM. So this is the fraction I am working on for my research in my PhD work, soil like material SLM. This is the material I am using. And then the medium fraction having mostly plastic, that is called the RDF, plastic, textiles, wood. So what are the combustible waste we'll call as combustible fraction, solid waste fractions. So that are all RDF we will call. And then the coarser particles are majorly consist of bricks, coconut shell, footwears, cloths. I will explain this with some other PPT also. I have separate PPT for biomining that I will explain in the extra class based on density separation. So this will be recovered, and we have different option, reuse option for different fractions. RDF we can use for road making. Bioearth we can use for landscaping or soil conditioner because it's majorly soil only. So they can be used as a agricultural soil. But after checking different contaminants present in the soil like material, it may have some heavy metal. It may also have some, although it have good nutrient capacity because it's from the waste. Even also it has some harmful heavy metals and toxic elements present in it. Okay, so major equipment used for excavation, shredding, screening, air classification, ferrous separation. These are the process. So we have different equipments involved. For screening, we can use trommel, vibrating screen, and disc screen. So trommel screen, you can see it's a drum kind of structure like this. So if you feed one waste here, so we have different holes having 100 mm dia, 4 mm dia, 6 mm dia. So if it is a 100 mm dia trommel, whatever the particle less than 100 mm will come out, whatever the particle greater than 100 mm will go out. So this is simple compost screen like structure, so that will segregate the waste. Okay, vibrating screen is the one which will vibrate, and based on the size it will be segregated. Disc screen having different star shape or disc shape, that will squeeze or separate the material based on the spacing between different discs. So if it is having this much space, what are the particle having less than this space, it will be coming out. That will be separated out. Then for handling, only for screening we have this much equipment, and for handling we have loaders, conveyors, and forklifts. We have lots of vehicles and equipment required for biomining. We need. And then this is one of the schematic flow chart for biomining process. We have lots of methods, practical feasible methods, successful methods we can say that I will explain in a separate PPT. This is one step. Like excavation, we have to do to a deep of 2 to 2.5 meter. First, we have to do all the process. Again, we have to go to next deeper layers. Okay, then first we need to do hand picking for larger particles like coconut shell, bricks, wood particles like that. Coarser particles we have to first hand pick. Then we have to do windrow composting method. As we did composting, the same windrow we have to follow windrow method. So this will aerate the every time we have to turn the waste. That will aerate the waste. We are also adding mist spray bioculture. So that will degrade what are the remaining material present in the solid waste. Then we have to turn the windrow every 2 to 3 days. After 20 days, we can do screening and we can get different fractions. Okay, when we have to close or closure and rehabilitation of old dump sites, once it reaches its full capacity, we have to reduce the waste by doing biomining. We can also do capping. We can also do capping with additional measures like cut-off walls and extraction wells to monitor the facilities. Okay, so in the dump site, if you first process excavation, like that, different earth movers and excavators we can use to dig up to 2 to 2.5 meter trenches we can make. Then hand picking of larger particles like rocks, coconut shells, long piece of textiles and plastic bags we can remove. Then windrow, multiple and single windrow we can do. This is for compost. The same we can do for legacy waste. Okay, long narrow pipes have to maximize the surface area to aerate with the atmospheric air. So every 2 to 3 days we have to turn. After 20 days, that is after third to fourth turning, we can screen the waste with this is the trommel screen I was discussing about. So with the different trommel screens, we can separate the fractions. So how to use the different fraction? That is the ultimate aim. So without identifying the application for different fraction, we should not start biomining. Otherwise, after separation, it will again be in the same land. So identify where the screening fraction will go. So look for the nearest industries that can use the plastic fraction or the combustible fraction, that is the RDF. So you can also use this RDF as a bitumen for hot mix plant, and also we can use for road making. We can also have a connection with the kabadi walas to collect that we can say rack pickers or kabadi walas. They will get this type of larger particles and they can resell. These are all recyclables we can give, pet bottles and all we can give. And then offsite aggregation space we need to store the waste, storage shed and things we and all we need. Transporters we need to have a good connection and networking. And then the finest fraction we can look for farmers, but after checking for the heavy metals. Periodic checking we need to do every month or at least 2 weeks once we have to check. If the contaminants are in low level, we can give to the farmers. Then process management. For a biomining process, we need to manage first space. Space is the biggest challenge because already the dump site is fully accumulated with the waste. How to go with this much vehicles and this much equipment and where to keep all the equipment and how to manage the space, that is the biggest challenge. So we have to do biomining within the boundaries. They won't allot any other space for biomining. So biomining should be done within the dump site space area available. So already overloaded dump site, we have to use the earth movers, advisors, operate. They will have a proper transport mechanism. They will easily climb to the higher elevation. They can do excavation. So we have to demarcate a smaller space for earthing this equipment. So then leachate management is second problem. So water logged with leachate near the topmost layer, because the topmost layer will be usually some fresh waste. So there will be lots of leachate accumulation, not just only from rainfall. It will also due to anaerobic digestion. There may be some water generation, leachate generation. So if you start excavation, all this leachate will trickle out. It will not produced by the formation of windrows or the cone. You can easily bioremediate and stop the leachate generation. Okay, so leachate management can be done with the proper channeling that can be collected and treated in a separate leachate treatment methods. Treated in a collection pond by, as I mentioned, leachate evaporation we can do. That will increase the concentration but reduce the volume to be treated. Then bioculture we can use to stabilize the leachate, and then intermittent aeration we can do. Success is noticed on how can we identify the leachate is stabilized or not? If it changes from the dark color to the light color, we can check by visual observation. We can say the leachate is degraded. Okay, then the third major challenge is fire control and safety, because whenever the methane is accumulated inside the landfill due to anaerobic digestion, methane and carbon dioxide will be produced. That will be inside the landfill. Once you start excavating, the methane will be liberated as a higher quantity, and if it is the summer season, then it will easily catch fire. Or some flammable industrial waste may be there. Already the waste is legacy waste and it is dry, having mostly combustible materials, and the methane also there. Easily it will catch fire, it will be spreading everywhere. So the fire management and the safety is the major issues. It's difficult to begin bioremediation once the smoking is come up. So there may be some hidden fires. So fire control is very important. So if you start adding water, it will again generate methane due to anaerobic condition, and it will generate leachate. So you have to add soil. If you add soil to reduce the fire, it will add a volume to the waste to be treated. So both are having some impacts. So the finest organic fraction will organic compost we can use for landscaping. Medium fractions like plastic and textile we can shred and use in the industries. Heavy metal fractions we can use for recycling. Inert material we can use in the landfills. So the what are the recovered space? How to use? So we have to put a signboard for the public not to use the recovered space for a minimum period of 15 years. So the cleared dump site should not be permitted for habitation for at least 15 years, because SWM rules itself, it's mentioned in the schedule 1 class H in the point 2, it's mentioned because we have some unhealthy leachate still may be present in the space recovered. There may be still some landfill gas that may be flammable. So we have to wait for 15 more years, and we have to regularly monitor the landfill site, that is the cleared landfill site, for any leachate production and gas production. Then after 15 years, we can reuse this landfill for open stadia, sports grounds, park gardens, parking lots, and container yards, and we can use this as a warehouse for non-flammables. Again, we should not keep some flammables there, because there may be some methane production. So if you see some of the case studies, like in Indore, Madhya Pradesh, you can have 15 a lakh metric ton of legacy waste was cleared. Indore was a pioneer in solid waste management. That's why they are the Swachh Bharat mission that was initially proposed in Indore only. That's the cleanest city in India. Recyclable polythene we can use for road making, they have used, and the soil recovered from that indoor site was used to refill the ground, and the CND waste recovered was used to produce building materials. In 3 years they have treated 15 lakh metric tons. You can also think about the land area, 100 acres of dump site they have cleared. So you think about the huge area that much recovered, you know about the cost of the land also. So after initial, after clearing, so you can see this is like a ground, initial, after, before, after, you can say. So you can reduce the environmental pollution, you can also have land area. So in Tamil Nadu, you can see about Kumbakonam. This is the first biomining process, I think, happened in India, in around 12 acres of prime land, having 1 lakh, 1.3 lakh meter cube of waste. The project cost is around 7 crores. And the main important thing is the plant achieved zero rejects. So there is no reject coming out from the biomining process. All the fraction that was utilized for some other purposes. So this is the Kumbakonam site before biomining. This is after biomining. So this is all about biomining. I have a separate slide lecture for a biomining itself, because my project is related to biomining. I will explain you in a separate class. And after 11th and 12th week, in 22nd of October, we have a special class, special problem solving session, extra class. Okay, you can also attend that. So now we can go with problems, older assignment problems. If you have any doubt with the landfill gas and biomining, you can please unmute and you can ask. Or else we'll move on to the problem solving session. Um, I hope the question is not there in the this week's assignment. I'll explain in the problem solving session. If you hear the whole lecture, you know there are five phases of leachate gas generation mechanism and leachate generation mechanism. In the first phase, that is aerobic. The second phase, so acidogenesis. Third phase, acetogenesis. So acidogenesis and acetogenesis are the two phases that the leachate pH of the leachate will be dropped. Both phases. Hope you got cleared in both phases. Because both are acid forming phase only. In acidogenesis also acid will be formed. In acetogenesis also all the acids will volatile fatty acid will be converted into acetic acid. So in both phases acid will be produced. So pH will be dropped. Shall I move on to the problem solving session? Please post the answers in the chat box. Like the A, B, C, D, like that you can post the option. Okay. This is the first question. What is or are the primary cause of landfill gas generation? Primary cause for landfill gas generation: volatilization, biological decomposition, chemical reaction, all the above. Uh, so we have discussed about the mechanism of landfill gas generation. So gas may be produced due to volatilization, biological decomposition, and chemical reaction. That is correct. Yeah. So this is what we have discussed in the first slide itself. Correct. Okay. So we will move on to the next question. So in which of the following phases of decomposition the pH of the leachate drops? So this is what the question we have asked. Yeah, aerobic phase, acidogenesis phase, acetogenesis phase, methane formation phase, and the fifth phase is maturation phase. So the answer is it's a multiple choice question. I have already answered this question. So answer is B and C. In both, so in the first phase, that is whatever the oxygen that is present, so it will be aerobic phase, it will be degraded, so it's aerobic phase. Oxygen will be depleted, then CO2 will be formed. In the third phase, methane will start forming, and in the fourth phase, both will be in a stabilized manner, and finally nitrogen will also get depleted. Finally it will be around 5% or something in the methane fermentation phase. Okay. Move on to the third question. Which of the following factors affect landfill gas generation? Temperature, pH, waste density, all the above, none of this. Sorry. Sir, it's not C. It's also C. pH, temperature, waste density. Why not the temperature will affects the landfill gas? Why everybody is saying C? I don't know. We'll check once. All the above is correct, yeah. We'll check with the presentation also. Factors affecting landfill gas generation, right? pH is there, temperature is there, waste composition, waste density, everything is there. Yeah, all the above is correct. Yeah, okay. Okay. So this is the thing we have discussed in the rule of hundreds. Rule of hundreds. So the pressure loss is directly proportional to quantity, the flow, that is the quantity of methane flow, and then diameter of the pipe, length of the pipe. So we have a rule of 100. Based on that, when the flow is 100 meter cube per hour and the diameter is 100 mm and the length is also 100 meter, then the pressure loss is 6 millibar. 100 meter only they are given as 100 mm they are given as 0.1 meter. Okay, so the answer is B. That's what correct. So everything will be 100 meter cube per hour. So all the fluid flow in a pipe will have a friction loss. So due to the friction loss, pressure will got reduced. So how much pressure will be reduced is based on the diameter of the pipe. If the diameter of the pipe is bigger, then pressure loss will be reduced. If the flow is very high, then pressure loss will be higher. So the formula indicates that the pressure loss is directly proportional to Q power 2 and inner diameter power 5, and we have a constant of 10,000 or something. So based on this, they have formed a rule, hundreds rule. Okay, 100 meter cube flow, if it is there, and the diameter of the pipe is 0.1, and length also we have a friction loss, and the diameter also we have a friction based on that. Okay, according to solid waste management rules, how many years should pass before a cleared dump can be used for habitation? 10 years, 15 years, 20 years, 25 years. Yeah, so it's mentioned in the solid waste management rule. The cleared site should not be used for habitation for up to at least 15 years. So 15 is correct. Yeah, at least 15, because what are the reasons? There may be some leachate present. There may be some landfill gas generation, flammable gas. So these are the two major problems. Okay, so this is about biomining. What is the which is the correct schematic representation of biomining through excavator by making windrow? First we will excavate, so that's correct. Then hand picking of large object, so this all are correct. Then before making windrow or after making windrow we will spray the bioculture. Windrow, I think D. Windrow making, then we will spray the mist, then windrow turning, then screening. Yes, that's correct. Because after making the windrow only, we can spray the mist, then we can turn the windrow every 2 to 3 days, then we can use that after 20 days, we can screen the waste. So excavation, hand picking of the large objects, we have to form the windrow, we have to spray the bioculture, we can turn the windrow every 2 to 3 days, then we, after 20 days or after the 3 to 4 turnings, we can screen the waste. Got it? Okay. We'll move on to the fourth question. Sorry, seventh. Factors affecting landfill gas transport mechanism. So we have studied about landfill gas generation mechanism, that is due to chemical reaction, biological decomposition and volatilization. Second one is landfill gas transport mechanism. This is generation, that is landfill gas transportation. That is factors affecting. First one is permeability, second one is geological condition, landfill cover and liner system, none of this. This is a multiple choice question. So absolutely permeability will be the answer. Because permeability, if it is more landfill gas will be transported. Geological condition, yeah, it's actually whenever we are having a clay liner or a clay rock bottom, the water table if it is there, then the landfill gas transport will be retarded. Then landfill cover and liner system, that is again a important thing. Geomembrane, or if we are using any kind of liner system, then also the transport gas will transport will be retarded. So all three are correct, I think. Yes. So A, B, C is correct. Fine. We will move on to eighth question. Which of the following should be tested time to time for bioearth? Microorganism, heavy metals, petrochemicals, radioactive elements. We have different fractions of biomining. One is larger particles, then refuse derived fuel, then the finest fraction, that is called bioearth. So the bioearth can be used in the used as a soil conditioner, but before using as a soil conditioner, it should be checked for heavy metals because it's very harmful toxic element. Because whenever we are using the bioearth for agricultural field, the plant will take this heavy metal and it will be accumulated. Again, we have to rely on the plant for food, so it will come into the food chain. So we have to avoid this heavy metal entering into the plant. So we have to check the bio for a proper heavy metal. If it is less than the FCO standards, as we already discussed about the FCO standards in the compost also, food and compost order FCO standards. They have given a guidelines that I have already. The guidelines were posted in the problem solution folder, Google Drive folder. You can check. So if all the heavy metals are within the limit based on FCO standards, then we can use the compost for uh, not landscaping, agricultural field. Okay. Then the ninth question: permissible option for reusing recovered landfill site. What are the option we can use for recovered landfill site after certain years? For open stadium, reuse for SWM, for flammable warehouse, all the above. After 15 years only, after certain years, that is 15 years. So we can plan for open stadium, okay. We can reuse for again solid waste management, like any MRF we can construct there, any compost plant we can construct there, any incineration plant we can construct. Not incineration because it's flammable. For flammable warehouse we should not use because warehouse we can use for non-flammables. So 1 and 2 are correct. Okay. Second question. What is the question? Why? Should I need to repeat? This is what I have answered, right? Acidogenesis and the acetogenesis. Still, you want clarification, sir? Hello. Can you unmute or you can post it in the chat box? Okay. So we have some more questions. This primary cause we have already discussed all the above. Okay. Flow 100 rule also we have already discussed. 100 mm per hour, 0.1 meter, 100 mm. Okay. And this we can answer. In which phase anaerobic condition starts developing during biological decomposition of the waste? Initial adjustment pH phase, acetogenesis phase, methane fermentation phase. In which phase anaerobic condition starts? So we have 5 phases. In the first aerobic phase, the O2 will get reduced. Second phase is, this is initial adjustment phase is first phase. Second phase is acidogenesis phase. Here only, this is aerobic. From here onwards, it's anaerobic. So answer is acidogenesis phase only it will form. Anaerobic condition will start. From acidogenesis to acetomethane, everything will be anaerobic. Okay. Which of the following pH drops? Acidogenesis and acetogenesis. Okay. Which is true about advection? So there are two mechanisms for gas transport. One is diffusion, another one is advection. So diffusion is called movement of gas from high concentration to low concentration. That is when concentration decreases. But advection is flow of gas from high pressure to low pressure region. So answer B is correct. Okay, sorry, it's a multiple choice question. So rate of gas movement is higher than diffusion. That is also correct for advection. Then geomembranes are used to stop advection. That is wrong because geomembrane won't stop the pressure difference. Okay, so these two are correct. Check for multiple choice in your exam also. Okay. The clear dump sites are not permitted for habitation for at least 15 years. That is correct. Okay, we have already answered. Principal mechanism for landfill gas transport: pumping, advection, and diffusion. All of this. Yeah, we have already. We are every week we are uploading this question in the site. You can check the problem solving session tab. I will show you now. Okay. So the answer is advection and diffusion. These are the two prevailing transport mechanism. Okay. Reduction of waste in the closed dump site is done by which process? Feeding to cattle, biomining, burning, none of this. So reduction of waste in the closed dump site is by biomining. Okay. So today we have today is the week 10 of 12-week course of municipal solid waste management in NPTEL. So today we have discussed about the landfill gas generation mechanism, factors, and then treatment collection system. And also we have discussed about the biomining. If you have any doubt, please unmute and ask. I will be there in the meeting for next 5 minutes. And you can also see this um, uh, what I can say presentation and the problem solving session presentation in Swayam portal. If you go to the course, you can see here. After all the week sessions, you can see here the problem solving session. Other two PMRF scholars are also taking parallelly for the same course. My weekly problem solving session is every Tuesday 6 to 8. So here you can see the problem solving session link. So if you click this link, you can be diverted to a Google sheet. Here you can see my presentation in the third one. So this is the presentation folder. If you go through the folder, these are all the old week videos you can access. And if you go to the folder, I have already uploaded every week lecture material. Every week, this is the combined lecture material what I am teaching. This is the same highlighted material what sir have posted. This problem solving material was prepared by me. The same PPT I have uploaded already. And then some of the problem formulas also I have updated. And then the reading material, additional reading material, my papers and this FCO standards as I mentioned, everything I have uploaded here. So you can check with this your Swayam portal tabs. Okay. If you have any doubt, please unmute and ask. Thank you so much. If you don't have any doubt, you can leave the meet. Thank you all. Thank you for joining. Thank you, ma'am. Thank you. So hope you have no doubts. Can I close the meet? Thank you so much for joining. I'll close the meet.